Welcome to UNI-T Training. Let's look at the UTS3000A real-time spectral analysis capability. Let's look at the UTS3000A real-time spectral analysis capability. First, we need to switch testing modes to real-time spectral analysis mode. Then we can set up parameters and start a test. What is the difference between a real-time spectrum analyzer and a general spectrum analyzer? General spectrum analyzers process the data after the signal is received. When processing the data, the instrument will stop receiving a signal. In that case, it works like a DSO oscilloscope, so there will be a dormant time of measurement. With a real-time spectrum analyzer, the signals can be received and analyzed at the same time. The capture rate is high. It works like a UPO series oscilloscope. So, for the real-time spectrum, a POI, which means percentage of capturing probability indicator, will be used as a specification. In addition to this, real-time spectrum analyzers can also measure wider bandwidth and has a higher data analysis and receives triggering capabilities. It can also measure PVT, power versus time of a spectrum. PVT represents relationship between power and time. What is showing now on the screen is a density of signal spectrum. The longitudinal axis represents power. The horizontal axis is the frequency. These colors indicate the probability and number of occurrences. It means how often the signal appears at a relative frequency points. For the places that have no color, there is no signal at the frequency points. Red means highest probability and blue means lowest probability. So we use X, Y, and color to represent three-dimensional properties. In addition to spectrum density, you can also select normal in the measurement settings to monitor basic spectrum scanning. In addition to spectrum monitoring features in it, there's also a waterfall chart. Waterfall charts can display a record of all the signals measured in a history. We can look at every historical trace on top of the horizontal axis. It represents the probability of each occurrence. The darker the color is, the more frequently the signal will appear. The upper one is the older signal. The lower one is the latest acquired signal. The process starts from the bottom. So we see that waterfall chart scrolls from the bottom to the top. Let's take another look at the density of the spectrum. The upper graph is the density of the spectrum and the lower one is the waterfall chart. Then PVT is a power versus time relationship. The longitudinal axis represents power. The horizontal axis represents time. If I want to set up an amplitude modulation signal at the signal generator, I put this acquire time to the minimum. This gives you a logarithmic waveform. It shows the envelope signal of a modulated wave. This can be done in the amplitude settings. Change the display scale to linear. This shows that it is a sine wave. Let's take this modulation wave and change it to a square wave. Now it appears to be a square wave. Now let's change it back to a logarithmic scale. In addition to the above window display mode, let's look at the PVT spectrum. The window above is the power time analysis graph. Below is the spectrogram. We can also change its acquire time. Let it appear as an envelope of modulation waves. Here are a few ways to display the window. It's all about what we've covered earlier. Combination of windows. I won't go into details. In real-time spectrum analysis, the density spectrum is used the most. Now let's demonstrate the template triggering feature in the Scan menu. Select Frequency Task Trigger in the trigger type. Is it possible to set the frequency that we care about? First, we'll edit the trigger. Click the Edit menu to insert a row. Edit the template you want to set. The red line box is the mask for our editing, equivalent to zone triggering. If I change the mask condition, no signal that was past the red line will be triggered. Been waiting for the triggering. Change the mask to a value that can contain the signal. There is already a signal in the red zone. This can be triggered. It's more versatile. It's about testing something that is not easy to find or sporadic signals. The capture rate of the real-time spectrum is very, very high. Currently, the UTS3000A series, the 100% capture rate is 6.68 microseconds, meaning the signal needs to be greater than 6.68 microseconds. Then we can capture the signal at 100%.